Hello, Twitter, Twitch, Facebook, LinkedIn, and YouTube. My name is Frank Lavinia, and you are watching another edition of Fedora Friday. All right, my name is Frank Lavinia, and I am a proud Red Hatter, and I am the global go-to-market lead for all of our data services, and I'm here today to talk to you about some big news. A couple of things. Remember, kids, this is not about Fedora, the operating system. This is about the hat. Fedora Fridays are when I put on my red hat and stream to you about all the goodness that we're doing here at Red Hat for data science and data engineering and everybody in between. So with that, big announcement this week, couple of big announcements. One, Red Hat has a new CEO, Matt Hicks, and we're excited about that. But also, RHODS, Red Hat OpenShift Data Science, now has GPU support. So to celebrate this, I've put up a little graphic. All right, so sorry for that annoying music and that loop repeating. There are some new features here in Restream that I'm experimenting with. The Red Hat deserves, yes, Thomas, I concur 100%. Deserves a crushed red velvet smoking jacket. I need to get me one of those because that would be suave and a little like pipe, maybe. You know, hat matching red. I like it. I like it. I actually just finished Jeff Fritz. I believe it was Jeff Fritz. He has a blazer class, and he was wearing a shiny, reflective purple blazer to promote that technology. And in case you're wondering, hey, Frank, what is the deal with this little QR code here? So next week, I'm hosting a webinar. It's free. It's primarily meant for partner organizations of Red Hat that have in the educational space where we can talk about RHODS and what RHODS can do for education. I will remove that graphic now and I'll pop it up later. But you can check it out. And thanks, Thomas, for tuning in live. And yeah, I concur, sir. I need a red velvet smoking jacket. Where will one? I guess Amazon? I don't know. I have a red hat, and that's enough. So for those of you that kind of saw, I had a should it go to the side or should it be flat? I don't know. So I actually had to schedule as an event in LinkedIn, but one of the things I kind of realized is I'm not exactly sure how the system works in conjunction with Restream, who has their own eventing system. So I decided to cancel the event and then stream anyway, kind of directly. But I will work through that and figure that out. But I do like your idea, Thomas, of the smoking jacket. That would be suave. That would be suave. All right. So Red Hat OpenShift Data Service, Science, and You. Basically, you probably have seen me talk about this in various streams over the last few months. But not only are we now limited availability, but also we now have GPU support. I'll spare you the video. Or can I mute the video? Here we go. Let's play the video. Breaking news. We now support GPUs. That didn't quite work out. Let's try that again. All right. Okay. So let's remove that. Uh, and put myself in the corner. Nobody puts Frank in the corner. So Red Hat OpenShift Data Science and You, how notebooks as a service can be the easy button for data science. Basically, what this I like to say is where we're going. Um, we will need roads, and that is a. Let's see, can I move that? No. Where we're going, we will need roads. So ultimately, you probably heard this phrase: "Is that data is the new oil." You probably heard the phrase that data is the new oil, but what does that exactly mean? Well, just like a refined oil has refined, is pulled out of the ground, it has no intrinsic value per se, but you can't really do anything with it. Um, Thomas, I love it. Nothing like using an old media for a newspaper announcement. Yeah, it's funny. I actually have not touched a newspaper in months, so I wonder if kids today even know what a newspaper is. Um, but yeah, so we're real excited to have this GPU support because it puts us on competitive with every other cloud-based service. Except we have one extra difference. There is going to be some announcements in the future that will make us even better. And but ultimately, if data is the new oil, AI is the new electricity because oil in and of itself, well, it has value, but it has to be refined. And this is very similar to the story that you have with data. So one of the things I like to point out, and load up that whiteboard while I get my stuff together. Um, but first, some context. So, what when people say data is the new oil, what exactly does that mean? And I am sharing a window or a screen. Hang on. There we go. What exactly does this mean? Well, and if you've attended any of my talks while I was at Microsoft, story is largely the same in the regards that let's see. So a few years ago, my kids really got into this idea of gem mining. And gem mining is basically you buy a bucket and for say $15, $20, you get a bucket. And you get a bucket, and this bucket is filled with dirt, but inside that dirt, there's a bunch of semi-precious gems in there. And ultimately, what you do is you run it through water, and you get the rocks out, right? Some of these rocks will have crystals inside of them, which then you have somebody who's a gemologist or someone in that trade. The best shops are the ones that have geologists, so not just gemologists, but they can tell you even more about the science behind the rock. There was one place we really liked in forget the name of the town, but it's called Doc's Rocks. So this person here will go through and tell you whether or not you have a crystal in there that's worth cutting out and basically turning into um, a more polished and refined crystal. And once you have that, you have the option of putting this into a setting like a ring, for jewelry purposes. So as we're doing this, it kind of reminded me of, hey, this is an awful lot like work, and not work in the sense of you actually have to. The kids love it because they get to get dirty and play with water and rocks. Uh, but this here is very analogous to the idea of raw data. And then this here are the little nuggets of truth that you pull out. And I would say that's kind of similar to business intelligence, right? The BI tools, the dashboards. Here's all the raw data. We filtered it down. We got rid of all the noise. We collated it. And now we have nuggets of wisdom. And we can kind of do that. We have that. Um, so going a step further, this is your data scientist, right? Because data science really picks up where BI drops off, right? And then this data scientist is the one who says, you know what, there's potential in here. We could create a model here. We could create something that adds significant value. And then this here is the AI model. Now, just like a precious gem, which is, in and of itself kind of valuable, it's not really valuable until it's put into production. And this is basically represents the production, right? Um, Typically, what you have is that on this side of things, you have a new role evolving called the ML engineer. And that's how I like to explain it. The idea of data is the new oil. If data is the new oil, then what does that mean exactly? And it's interesting to note because, you can have all the data in the world, but if you don't do anything with it, you can't use it in any kind of significant business sense. Furthermore, another way to look at this, and I've heard this kind of brought out, is the term data estate. Well, what exactly does that mean? Well, data estate is essentially, it terms from most of human history. Wealth and power were basically based on land, because on land you can grow food, you can mine, for gems, you can mine for fuel, you can grow trees. Trees are building materials. They can be used for wood. You can basically, and there's also rocks, which you can use for, weapons and fortifications and things like that. But how does this apply to kind of data? That is kind of like, time immemorial, what those economic systems look like. So how do we make it so that the data estate, like, what does that exactly mean? Right? Well, the data estate is like the land. Data is like the land. And data estate is the data that you own. So ultimately, you can refine all of these raw natural resources into something useful, like artificial intelligence, like computer vision models, like BI, right? Another way to look at it is everybody's got data, and it's a bit like this, right? In its raw state, it's not really usable, right? But with a little bit of work, you can make it something usable, right? And then, if you're really savvy, you can integrate it with your applications and have it do something even more useful. The short of it is, the data in and of itself has value, but it's kind of the chicken or the egg. Does the data have value, or what you do with the data has value? And you see that with companies like Facebook, um, Uber. They release a lot of the tools that they use. Netflix, right? All the algorithm to get a recommendation system came from Kaggle, I believe. They were the winning submission. Kaggle, if you're not familiar, is a data science kind of petition site. And what happens is that without the data, that algorithm isn't really worth anything, right? You have to have the mass quantities of data that companies like Uber, Facebook, and Netflix have in order to put that to use. So they can safely, as it were, open source the structure and construction models for how to build a refinery. But without that raw resource, that raw material, it's effectively, I wouldn't say worthless, but you're not going to get anything done with it. That's why they do it. Do they do it strictly out of the goodness of their heart? Well, you'd have to ask them. Or do they do it because they can take advantage of an open ecosystem where open source doesn't have to be a zero-sum game? So with that in mind, let's see if we can go back to my slide deck, hopefully. So that's the context. Let me put myself back in the corner. So data science teams. So where does RHODS fit into all this? Well, data science teams, um, they tend to operate independently of central IT. They tend to be inside the business units. They've really only started to consider kind of that whole life cycle aspect of it, right? Um, they're accustomed to kind of running their own show and kind of doing what they want because they were the unicorns. Now, governance is probably going to be the next great frontier in data, data engineering and data management. Governance is strictly what's interesting about governance is that governance is probably about 20% about technology and 80% about people. Technology can change, but people's habits and way of thinking don't change that much, or they change very painfully. All right, so what are the pain points for data science teams, right? High peaks of activity, the high variability of compute. You can, if you buy a top of the line GPU'd out desktop or laptop, you're not going to be, unless you're spinning that 24/7, it's kind of a waste of activity. There's also the aspect of replicating, bringing new team members up to speed. How do you do that? Well, basically, you do a lot of troubleshooting, right? Which is a zero value activity. So what does an enterprise data science team roles and responsibilities look like? Well, obviously, you have the business leadership setting the goals. You have data engineers. Big shout out to my data engineers out there. Hello, Andy. Um, and they are the ones that gather and prepare the data, right? First, you get the data. That alone can, those 5 words can be months of work. You have the data scientists then take that raw material and then work with it, right? So the data engineer is the one that loads the the dirt into the bucket, loads the bucket, hands you the bucket, maybe even does some initial cleaning of it, and then it's the data scientist that takes the rock and kind of takes a look at it and see what's going on. The ML engineer, you'll see there's some overlap in those activities, but the ML engineer basically is the one that will do the cutting of the rock, as it were, and even put it into a setting, into a necklace, into a ring, using my analogy from before. And IT operations tends to be involved basically from the data engineering side all the way to deployment. And then what happens is that because models will drift over time, just the same reason that it's something wrong with the models, it's just the situation on the ground changes, reality changes. There's no way to produce a model as of yet that can take into account all of the entropy in the universe. That doesn't exist. So what happens is the model will kind of start deviating from, and its performance will start to suffer, and then you can go back, retrain the model, and then the process begins again. Now, a lot of data science teams are not really familiar with that process now. This is a process that's coming into its own now. And this is where it's interesting because if you replace the word data model, data and data model and model, this could easily look like a DevOps diagram, couldn't it? So this is really kind of the genesis of ML ops. A lot of these problems, this process problem has been solved. It's been solved for a better part of a decade now with DevOps. So bringing the DevOps discipline into the realm of data science and AI is really kind of where the rubber meets the road next. So let's take a look at each individual participant in this a little more closely. Data scientists, right? What do they want? Well, they want access to the best compute services. They want to get an environment up and running. As a data scientist, I can assure you personally, I do not enjoy troubleshooting CUDA drivers. I once, in fact, bricked a Surface notebook because I was mucking around with the drivers because the first version of the Surface Book was it had a it did have um, it actually did have a NVIDIA card, but it didn't quite have a proper NVIDIA card with discrete separate drivers. So yeah, I don't have fond memories of that. I started my career in tech support. It has helped me well, but it's not a skill I particularly or a task I particularly enjoy. So challenges are limited resources, right? If I'm using my desktop, my laptop, I may not have the best and the brightest GPU out there. And again, the troubleshooting. An ML engineer, well, most of the time, this is a very blurry line between where does the data scientist start and where does the ML engineer start. This is a matter of debate, but basically, the machine learning engineer is the one that either creates the model, but also follows through and works with app developers, right? So they have to collaborate with developers. They also want the best computing resources. Their challenges are sharing code across boundaries and basically managing the model throughout its life cycle. IT operations, their priorities are controlling costs and compliance and risk. And they just want better governance on this, right? Because data scientists are used to working kind of on their own as separate little special unicorns. But as data science becomes a core enterprise function, this needs to be corralled, right? This has to be brought into order. And how do you do that? Well, you have to make it simple. You have to make it a managed service. You want it supported and you want it scalable. And fortunately, for you and the world, Red Hat OpenShift Data Science is all of those things. It's simple, easy to get started, simple to maintain. Red Hat, the royal we at Red Hat, we take care of all the underlying infrastructure for it, and we do all of this. It's managed, right? There's no infrastructure to deal with, right? All the patches and security updates, they're handled for you. It's supported. It's fully backed by Red Hat's site SRE, and it's fully supported and patched. It's scalable, like any respectable cloud service. It's scalable. It goes up when you need it, and it goes down the same cost when you don't need it. So ultimately, anybody can really, benefit from a product like RHODS, right? It's essentially an easy button. You stand up a RHODS cluster with a few clicks of a button, and it's all done for you. And now you can get GPUs. You can really crank up the power. Now I point this out, and so obviously, for those who have been following me on YouTube for a while, I do a lot of video editing. I do a lot of special effects. You watch some of the videos. I posted one today with velociraptors coming out of the screen, which was a cool effect. I do this, right? But one of the things that really, really matters is so one of the things I was doing, and I'm going to try to do this side by side on my screen. Let's see if this works. So ultimately, I watched this YouTube channel called Film Riot, right? And it's not showing, so I'm going to abandon this. I'm always experimenting. So I watched this YouTuber channel called Film Riot, and he basically he started off as a film student, and he documented on this YouTube channel over the course of the last 10 years his to basically a filmmaker. And throughout the process, he does really cool demos and shows you how to do special effects. May have seen some of this. I made a former Microsoft colleague one's beam in, like on Star Trek. Little effects like that. I have fun with it. But I also do a lot of 3D rendering. So and a lot of 3D rendering with like After Effects. So he once showcased his new rig, and this is a few years ago now. His new PC rig. It basically, I went to price it out. It was $13,000. Now, I got serious hardware envy. And so just as I went to think about asking the wife, hey, honey, what if we sold a car and I replaced it with a PC? Now, fortunately, I stopped myself and I realized, wait a minute, what if I set up a VM in Azure? I'll spec it out. I'll make it top of the line, right? And it worked out to about $75 an hour to run. Now, for me, I did an experiment, a rendering job that took on my PC, my local PC, about 12 hours to render, was done in this VM, the spec'd out VM, in about 45 minutes. Net, by the time I spun it up and spun it down, the cost was about $75, give or take. This, if I were to upgrade, would have been $13,000. Now, I don't know about you, But going to my wife with honey, I spent $13,000 is a radically different type of conversation than honey, I spent $75. And I think that is a good analogy for the cloud, right? Now, it works out. I did the math that if I was running this VM for 24/7, then in about 6 weeks time, I would spend about 13K, which would make this, if again, it makes sense because he does it professionally. He has this thing spinning much more often than I do, than my 3-4 times a year, although I am doing it more. But you know, it makes sense for him. It made sense for him to do it on prem, which I think again is a nice way to think about the cloud. For some people, doing it on prem, doing it on your own, dropping $13,000 or whatever amount of money on an on-prem hardware that you can use. You can have that thing as a, I've heard, glowing red 24/7. Yeah, then that makes sense. If you're not, it starts to become not making any sense. And there's always that line where the line is blurry. Clearly for him, it made perfect sense. For me, I do it 3-4 times a year, sometimes more. Let's just say once a month, I get a render going. And if I needed it really fast, it makes sense for me to kind of offload that onto a VM. If you're doing it more than that, probably wouldn't make sense. But as I get closer to that 24/7, it makes a lot more sense. So it's not a matter of always cloud or never cloud. It's always kind of like it mostly depends, right? It's that infamous phrase, those infamous two words. It depends, and it really depends. Now, in an enterprise world, I would say most people can benefit from the cloud, but there are use cases where, maybe not so much. But this is a good example of kind of two extremes. All right, so. But the advantage of this is that even if you work at an organization or an enterprise that has on-prem data centers, you may have to get permission to use it, or time to spin things up. This lets you immediately experiment, or better yet, if you're trying to train your staff and you don't want to waste kind of the production resources, you can spin up a RHODS cluster and have them go through a data science class, and they can learn on their own. Right? It's great for that type of environment. Right? So this is an example of real-time data from a previous customer that was Boston University. Kind of goes through as demand peaked, as assignments were due. You'll see that the number of clusters spun up and they spun down. You can also control costs in RHODS by limiting the amount of storage space that's used, by stopping idle notebooks. So you're not paying to have these machines running 24/7 when they're not running 24/7. You can also use we have predefined notebook images. So if you want to get going with CUDA, or you want to start messing around with OpenVINO, you don't need to install anything, right? CUDA brings back some some bad memories, like troubleshooting CUDA on a kind of sort of NVIDIA GPU, but not really an officially supported one. And then bricking my Surface Book. Yeah, that's not something I really want to do. And with this type of technology, I don't have to. And if that's not enough for you, well, check this out. You can actually define your own custom images. So what this does, I mentioned shadow IT. What this will help do is eliminate shadow IT, or at least give data scientists an incentive to start declaring what dependencies they're taking on. Because this way, if I say, hey, I'm going to need this library, this tool, this, and this, then they can install it as part of a predefined images. So if I go on vacation and the person in the cube next to me, or I guess a teammate, because not everybody's back in the office, I can just say, here, use this image, get started. Here's my notebook. Bada bing, bada boom, as they would say back home. So moving along, I like to think of this, speaking of rendering, speaking of that sort of thing, this is basically notebooks as a service, and you're a few clicks away. And with that, I'll take any questions that I have. We can talk about what the success we had at Boston University. In the meantime, they basically wanted to develop a general platform for the entire university, so they can work on open textbooks. So what's cool about Jupyter Notebooks is that you can combine code, images, and text in one format that's browser based. So what this means is you can actually um, you can go through and create textbooks, right? Interactive textbooks, right? You can have this open source textbook type mentality. A lot of schools are adopting this. And what this means is that as a professor and in a field that is continually evolving, like AI or data science or any of the research type work, I can share my material in real time or near real time. That's very impactful. And the other pain point was that you would have customers, students in this case, would have to offset the technical debt. And students are already have enough debt to deal with. So why would they want to deal with this as well? But what this meant was, if you look right here, office hours, right? When you want to talk to your professor about the actual subject material, it became tech support hours. Then there's also the matter of, the laptop ate my homework, right? So there's all these types of problems that by using a pre-built, pre-managed cloud service, that's how this gets addressed. So with that, there are no questions live. If you have any questions, feel free to post them in the chat. I will be watching. And in the meantime, you have a great weekend, and I'll see you for Metaverse Monday. And with that, I'm going to end the stream. Thanks for tuning in. Thanks, Thomas, for the real-time commentary. You have a great weekend. And I'm going to put this back on. I need to get a case for this so when I travel, I can bring it with me, like for conferences and stuff. Or just in general. I don't know. How's it look on me? Is red my color? All right. Be kind in the comments. Have a good one.